liftoff. We have liftoff.
For decades, the United States led humanity's efforts beyond Earth. The Apollo missions of the 1960s and 70s made history, putting the first humans on the moon. But after Apollo 17 in 1972, the US shifted its focus. Because of that, a new player has entered the scene: China. Through a series of ambitious missions, China has not only landed on the moon, but made a discovery so groundbreaking that it sent shockwaves through the global space community. How did China surpass expectations? What did they find on the moon that even NASA hadn't? This is the story of how China's lunar program stunned the world and overtook the US in the race back to the moon.
我觉得这是最主要的，以后还要一步一步要拿到样品。
For much of the 20th century, the moon was a battlefield in the space race between the United States and the Soviet Union. The Cold War rivalry drove both nations to push the boundaries of technology, leading to historic moments like the Thaw 1969 landing of Apollo 1169. But by the time the dust settled, the US had claimed victory and global interest in lunar exploration declined. Meanwhile, China watched and learned. Unlike the frantic pace of the Cold War space race, China's approach was strategic and methodical. While the US and the Soviet Union had rushed to plant flags, China took its time, building a space program from the ground up. By the 21st century, they were ready to make their move. The Chang'e program. China's lunar ambitions were first outlined in the early 2000s with the Chang'e program, named after the Chinese moon goddess. The plan wasn't just about reaching the moon, it was about mastering every aspect of space exploration, from orbiting to landing, sample return, and eventually human missions. The Chang'e missions were divided into 3 phases. 1. Orbital missions, mapping and studying the moon from orbit. 2nd. Landing missions, deploying rovers to explore the surface. 3. Sample return missions, bringing lunar material back to Earth for study. This methodical plan ensured that every stew was built on the last. The first major milestone came in 2007 when China sent its first spacecraft to the moon. Chang'e 1, China's first step. On October 24, 2007, China launched Chang'e 1, marking its official entry into lunar exploration. While the US and Soviet Union had sent countless missions before, this was a monumental step for China. It proved they could reach and study the moon independently. Chang'e 1 was an orbiter, meaning it didn't land, but instead circled the moon while gathering valuable data. The spacecraft spent over a year in lunar orbit, mapping the entire surface in unprecedented detail. Key achievements: high-resolution 3D mapping. Chang'e 1 produced the most detailed topographic maps of the moon ever made at the time. These maps provided essential information for future landing sites. Mineral composition analysis. Using special imaging technology, the orbiter identified the distribution of minerals across the lunar surface, helping scientists understand the moon's geological history. Verification of China's deep space network. This mission tested China's ability to communicate with a spacecraft nearly 400,000 kilometers away. It was a crucial step in proving that China had the infrastructure to support future missions. Intentional lunar impact. After completing its mission, Chang'e deliberately crashed into the moon's surface in March 2009. This wasn't a failure, it was a planned maneuver to study the impact and gather additional data. Though it didn't make global headlines, Chang'e 1 was a major success. It laid the groundwork for what would come next, a mission that would push China's lunar capabilities even further, and they moved toward Chang'e 2. Next leap forward. Just 3 years after Chang'e 1, China launched its second lunar probe Chang'e 2 on October 1st, 2010. This mission was not just a repeat, it was a technological leap forward. While Chang'e 1 had been about exploration, Chang'e 2 had a clear objective: to prepare for a future landing mission. It had several major upgrades, making it one of the most advanced lunar orbiters ever sent into space. Key achievements: ultra-high resolution imaging. The spacecraft captured images with a resolution of 1.3 meters per pixel, far sharper than anything produced before. This was critical in selecting the best landing sites for future missions. Low orbit operations. Unlike its predecessor, which orbited at around 200 kilometers above the moon, Chang'e 2 dipped as low as 15 kilometers above the surface to get even closer looks at potential landing zones. Extreme speed and precision. The mission proved China's ability to conduct complex space maneuvers with extreme precision. Chang'e 2 reached the moon in just 4 days, a record-breaking time, much faster than past missions. But what made Chang'e 2 truly remarkable was what happened after its primary mission ended. Instead of crashing into the moon like Chang'e 1, China decided to take an unprecedented step, sending Chang'e 2 into deep space. In 2012, it flew past the asteroid 4179 Totatis, making China only the 4th nation after the US, Soviet Union, and European Space Agency to conduct a successful asteroid flyby. It continued traveling into deep space, eventually reaching over 10 million kilometers from Earth, setting a record for China's furthest space exploration at the time. This move demonstrated China's growing ambition. They weren't just interested in the moon, they were developing the skills needed for future interplanetary missions. These missions were critical. Though they weren't landing missions, Chang'e 1 and Chang'e 2 were vital in proving that China was ready to compete in space exploration. They built confidence, gathered essential data, and demonstrated technological capabilities that set the stage for the real breakthroughs to come: lunar landings. With the information from these missions, China now had the maps, the mineral data, and the technical expertise needed to take the next step. The world took notice, but few realized just how quickly China was advancing, and the next mission, Chang'e 3, would change everything. At the turn of the 21st century, the world saw space as a domain still dominated by NASA and Roscosmos. But in just a few years, China had proven itself as a serious contender. The Chang'e program was not just a national effort, it was a statement. China wasn't just exploring the moon, they were preparing to stay. They weren't just following in the footsteps of the US and Soviet Union, they were carving their own path. And most importantly, they weren't racing to the moon, they were strategically positioning themselves for long-term dominance. With Chang'e 1 and 2 completed, China was ready to take the next step. In 2013, they achieved something no country had done in nearly 40 years, a successful lunar landing, and this time, the world was watching. Starting a journey. For nearly 40 years, no country had successfully landed on the moon. The Soviet Union had made its last lunar landing in 1976, and the US had shifted its focus away from the moon after Apollo 17 in 1972. While robotic probes continued to orbit and study the lunar surface, no nation had dared to attempt another landing. But China was different. It wasn't just interested in studying the moon, it wanted to land, explore, and establish a long-term presence. The Chang'e program had already proven that China could reach and map the moon. Now it was time for the next step, putting a lander and a rover on the surface. First moon landing. On December 14, 2013, China made history by landing the Chang'e 3 spacecraft on the moon. This was China's first soft landing on another celestial body and the first controlled lunar landing by any country since 1976. Unlike previous missions that had simply orbited the moon, Chang'e 3 touched down in Sinus Iridum, the Bay of Rainbows, a vast volcanic plain that had never been explored before. Moments after landing, it deployed its rover, U2 Jade Rabbit, China's first robotic explorer on the moon. What made Chang'e 3 special? Chang'e 3 was more than just a routine lunar mission. It brought several technological advancements that set the stage for China's future space ambitions. Precision landing. Unlike Apollo-era landings that required human pilots to guide the spacecraft, Chang'e 3 was fully automated. It used advanced cameras and sensors to analyze the terrain in real time, avoiding hazards before landing. Scientific instruments. The lander carried the first astronomical telescope ever placed on the moon, capable of observing deep space in ultraviolet light, something impossible from Earth due to our atmosphere. U2 rover's capabilities. U2 was equipped with a ground-penetrating radar to study the lunar subsurface and instruments to analyze soil composition, providing insights into the moon's volcanic history. Challenges and setbacks. U2 initially performed well, but after just 42 days, the rover suffered a mobility failure due to extreme cold during the lunar night when the temperature dropped to 292 Fahrenheit or 180 Celsius. Though it lost movement, it continued to transmit valuable data for nearly 2 years, exceeding expectations. Despite this setback, Chang'e 3 was an undeniable success. China had proven it could land on the moon, marking a turning point in the global space race. But this was just the beginning. China had its sights set on an even more ambitious goal and started preparing to move toward Chang'e 4. far side of the moon. After the success of Chang'e 3, China wasn't content with simply repeating the achievement. Instead, it aimed for something no country had ever done before, landing on the far side of the moon. Why was this significant? The far side of the moon is completely different from the near side. It is rougher, more mountainous, and heavily cratered, making a landing far more difficult, even more challenging. Earth and the moon are tidally locked, meaning the far side never faces Earth, making direct communication impossible. To solve this, China launched a relay satellite, Queqiao, into orbit around the moon. Queqiao acted as a bridge, allowing the lander and rover to send data back to Earth. This innovative approach demonstrated China's technological sophistication and problem-solving ability. On January 3, 2019, Chang'e 4 became the first spacecraft in history to land on the far side of the moon, touching down in the Von Karman crater within the South Pole Aitken Basin, one of the largest and oldest impact craters in the solar system. Chang'e 4 discoveries. With its lander and rover U-22 or Jade Rabbit 2, Chang'e 4 conducted groundbreaking science. 1. New insights into the moon's interior. U-22's ground-penetrating radar scanned deeper beneath the lunar surface than ever before, revealing multiple layers of ancient lava flows. This confirmed that the moon had a much more complex volcanic history than previously believed. Second, evidence of materials from the deep moon mantle. Chang'e 4 detected unusual minerals like olivine and pyroxene, believed to have come from the moon's mantle. This suggested that a massive ancient impact had brought mantle material to the surface, providing a rare opportunity to study the moon's deep interior. 3. The lunar radio quiet zone. The far side of the moon is completely shielded from Earth's radio noise, making it the perfect location for radio astronomy. Chang'e 4's instruments confirmed that this region could be ideal for future deep space radio telescopes, potentially giving scientists a clearer view of the universe. These discoveries were game-changing, not just for China, but for the entire field of lunar science. The mission demonstrated that the far side of the moon was an untapped goldmine of scientific potential. Now, with these discoveries, we can finally analyze. China versus Apollo missions. The US had landed astronauts on the moon 6 times during the Apollo program, but their focus was different. Apollo missions were human space flights, meaning they had to bring astronauts back safely, limiting the time they could stay and the areas they could explore. China, on the other hand, was playing the long game. Instead of sending astronauts, it was using robots to methodically explore the moon map, analyze the geology, and test new technologies before committing to human landings. This cautious, step-by-step approach was very different from the US-Soviet space race, and it was paying off. While NASA had been forced to abandon moon missions after Apollo, China's robotic missions were steadily increasing in complexity and ambition. Here, a question came into everyone's mind. What's next? Chang'e 3 and Chang'e 4 proved that China could land on the moon and conduct groundbreaking scientific research. But these were just the first steps in China's larger vision. Chang'e 5, 2020. The first Chinese mission to return lunar samples to Earth, bringing back moon rocks for the first time since the 1970s. Chang'e 6, planned for 2024. Another sample return mission, this time from the far side of the moon, something that has never been attempted before. Chang'e 7 and 8, late 2020s. These missions will scout the lunar South Pole, searching for ice deposits that could support a permanent human base. China's Lunar Research Station, 2030s. China aims to establish a permanent presence on the moon, positioning itself as the leader in lunar exploration. By successfully landing not once, but twice on the moon, China had proven that it was no longer a secondary player in space exploration. The bold decision to land on the far side of the moon, where no nation had gone before, sent a clear message. China wasn't just catching up to the US and Russia, it was surpassing them in key areas. The ability to land, explore, and conduct advanced science showed that China was ready to shape the future of lunar exploration. And most importantly, this was just the beginning. The world was watching, and what China did next would change the space race forever. For decades, bringing lunar samples back to Earth was something only the US and the Soviet Union had accomplished, and that was during the Cold War. The last time moon rocks were brought back was in 1976 when the Soviet Luna 24 mission retrieved about 170 grams of lunar soil. Since then, no nation has attempted such a mission, but in 2020, China did what hadn't been done in 44 years, and what they found changed everything. bringing moon to Earth. On December 1st, 2020, China's Chang'e 5 spacecraft successfully landed on the moon in the Oceanus Procellarum region, also known as the Ocean of Storms. This area had never been visited by previous sample return missions, meaning whatever China collected would be new to science. Unlike previous landers, Chang'e 5 wasn't just there to explore. It had one job: collect samples and bring them home. This mission was one of the most ambitious robotic space missions ever attempted. It involved a lander to scoop up lunar soil and drill beneath the surface, an ascent vehicle to launch the samples back into orbit, a service module to bring them back to Earth, a re-entry capsule to survive the fiery return through Earth's atmosphere. In just 2 days, the lander collected 3.8 pounds, 1.73 kilograms of lunar soil and rock samples, sealed them inside a capsule, and blasted off from the moon, a move that had never been done before by an unmanned spacecraft. By December 17, 2020, Chang'e 5's return capsule landed safely in Inner Mongolia, making China only the third nation in history to retrieve moon samples. But what scientists found inside those samples was far more valuable than anyone expected. New lunar mineral. Among the collected moon rocks, Chinese scientists discovered a brand new mineral, one that had never been seen before on Earth or in previous Apollo samples. They named it Chang'e-Y after China's lunar program. This phosphate mineral was unique because it contained traces of helium-3, an incredibly rare isotope that has fascinated scientists for decades. Why is helium-3 important? Helium-3 is almost non-existent on Earth, but it has been detected in large quantities on the moon. Scientists have long believed that helium-3 could be the key to nuclear fusion energy, a potential clean, nearly limitless power source. Unlike traditional nuclear reactions, which produce dangerous waste, helium-3 fusion doesn't create radioactive byproducts. It could power entire cities with no environmental damage. The problem? Earth doesn't have enough helium-3 to make this a reality, but now China had found a confirmed source of helium-3 on the moon, and that changed everything. Global lunar resource race. The discovery of Chang'e-Y and its helium-3 content sent shockwaves through the global space industry. Up until this point, most lunar missions had focused on science and exploration, but now the moon was being seen as a strategic asset, a potential gold mine for future energy resources. Why is the moon so rich in helium-3? The sun constantly releases helium-3 in its solar wind, but Earth's magnetic field blocks most of it from reaching the surface. The moon, however, has no protective magnetic field, meaning helium-3 has been accumulating in its soil for billions of years. Scientists estimate that the moon's top layer of soil contains around 1.1 million metric tons of helium-3. Even a small fraction of this could provide energy for the entire planet for centuries. The discovery immediately raised concerns among US and Western space agencies. If China controlled the largest helium-3 deposits, it could dominate the future of energy production. The US reaction. The discovery of helium-3 reshaped the modern space race. For decades, the US had been the leader in lunar exploration, but now China was taking the lead in an area that could define the future of energy. The US and other space agencies quickly ramped up their lunar programs in response. NASA's Artemis program announced plans to return astronauts to the moon by the mid-2020s, with a focus on lunar resource extraction. Private companies like SpaceX and Blue Origin accelerated their lunar projects, hoping to secure mining rights on the moon. The US government signed the Artemis Accords, a series of agreements with allies to ensure fair use of lunar resources, a clear sign that competition over moon mining was heating up. But China wasn't slowing down. China's space agency quickly announced its own long-term plans for the moon, including Chang'e 6, 2024, a second sample return mission, this time from the far side of the moon, Chang'e 7 and 8, late 2020s, missions to explore the lunar South Pole, where water ice has been detected, a critical resource for sustaining a future lunar base, International Lunar Research Station, 2030s, a permanent Chinese base on the moon, likely built with Russia's cooperation. The message was clear. China wasn't just collecting moon rocks, it was preparing to stay. The future of lunar mining. With helium-3 now confirmed in the moon's soil, the next big question is, who will control it? China's discovery of Chang'e-Y wasn't just a scientific breakthrough, it was an economic and geopolitical game changer. Challenges of helium-3 mining. Even though helium-3 is present on the moon, mining it will be extremely difficult. It requires digging up massive amounts of lunar soil, roughly 100 tons of regolith, just to extract 1 gram of helium-3. Transporting helium-3 back to Earth is expensive. Current rockets would need major improvements to make lunar mining profitable. No fusion reactors are currently capable of using helium-3, though many scientists believe this could change within a few decades. But despite these challenges, the potential rewards are too big to ignore. A lunar energy revolution. If scientists can develop helium-3 fusion reactors, the moon could become the ultimate energy source for Earth and future space colonies. Just 25 tons of helium-3 could power the entire US for a year, without pollution, radiation, and reliance on fossil fuels. And now, thanks to China's Chang'e 5 mission, we know exactly where to find it. Chang'e 5 didn't just bring back moon rocks, it brought back a vision of the future. The discovery of Change Site, Y, and helium-3 sent a clear message. The moon is more than just a space destination, it's a future energy hub. Whoever controls helium-3 could control the world's energy supply. China's space program is no longer following the US, it's setting the pace. The next phase of the space race isn't just about exploration, it's about resources, energy, and the future of humanity itself. And China's discovery may have just given them the upper hand. Overtaking the US. China's ambitions in space have never been clearer. While the US was once the undisputed leader in lunar exploration, China is now setting the pace, and their next step is far more ambitious than simply landing rovers. The ultimate goal? A permanent human presence on the moon, and they've already started making it a reality. Lunar South Pole Mission. China's next major objective is the lunar South Pole, a region believed to hold vast reserves of water ice buried beneath the surface. Why is this important? Because water on the moon isn't just for drinking. It can be converted into oxygen for astronauts to breathe, split into hydrogen and oxygen to create rocket fuel, enabling deep space missions, used to support agriculture for long-term lunar habitation. For decades, the moon's South Pole has been a high priority target for space agencies. Unlike the equatorial regions where Apollo missions landed, some areas of the South Pole remain in near permanent sunlight, making them ideal for solar power generation. China's plan? Get there first and establish a long-term foothold before anyone else. Their upcoming missions are set to lay the groundwork. Second sample mission. China isn't done collecting lunar samples. Chang'e 6 will attempt to bring back material from the far side of the moon, a feat that has never been accomplished before. Scientists believe this region could hold clues to the moon's deep history and potential resources, searching for water. This mission is designed to locate and analyze water ice deposits in permanently shadowed craters at the South Pole. It will carry a lander to examine the surface, a rover to explore deep craters where water might be hiding, an orbiter to create detailed maps of potential landing sites for future missions. If Chang'e 7 confirms large water reserves, China will be one step closer to establishing a permanent base. Lunar Base. Chang'e 8 will go beyond exploration. Its primary mission is to test in situ resource utilization, ISRU, meaning it will try to use moon materials to build structures, create oxygen, and support life. This could involve testing 3D printing technology to construct shelters using lunar soil. If successful, this mission will lay the foundation for a permanent Chinese moon base. China's long-term plans. China has openly announced plans for an International Lunar Research Station, ILRS, by the 2030s. Unlike past missions, this will not be a short-term visit. China wants to build a sustainable moon settlement. Here's what they envision: a human-tended outpost where astronauts can live and work for extended periods. Lunar laboratories where scientists can research moon materials, radiation, and potential energy sources. Helium-3 extraction, turning the moon into a potential energy hub, a launch pad for deep space missions, reducing the need for heavy launches from Earth. To make this happen, China has partnered with Russia and has invited other nations to join, unlike NASA's Artemis Accords, which focus on international cooperation under US leadership. The ILRS is being developed as a China-led initiative. This means that, if successful, China could control one of the most important locations on the moon. But wait, it's not done here. The US also has its plans. Artemis program. China's rapid advancements have put pressure on NASA. For decades, the US had little urgency to return to the moon, but now, with China pushing forward, the US has revived its lunar ambitions with the Artemis program. Artemis the Free 2022. A successful uncrewed mission tested the Orion spacecraft around the moon. Artemis 2 2025. Planned to be the first crewed mission to orbit the moon since Apollo 17. Artemis 3 2026 to 2027. NASA's first planned human landing on the moon in over 50 years, targeting the lunar South Pole. Artemis 3 will be a direct race against China. If successful, it will establish the first US presence at the lunar South Pole, where China is also aiming to land. But while China is planning a full-fledged moon base, NASA's approach is different. Instead of a permanent base on the surface, the US is focusing on the Lunar Gateway, a planned space station orbiting the moon to serve as a hub for future missions. Private partnerships, companies like SpaceX and Blue Origin are expected to play a major role in lunar development. The key difference: China's plan is more centralized, while the US is relying on international and private sector cooperation. New space race. Unlike the Cold War-era space race, which was about national pride and technological achievement, today's space race is about something much bigger, controlling lunar resources, water, helium-3, and other valuable minerals, establishing permanent settlements. Whoever builds the first moon base will have a major advantage in future space expansion. Shaping the future of space law, the first nation to control moon resources could influence global space policy. In 1967, the Outer Space Treaty was signed, declaring that no nation could claim ownership of celestial bodies. But this treaty was written before anyone seriously considered resource extraction and long-term lunar habitation. Now, with China and the US both racing toward the moon's south pole, there's a growing debate: who gets to control the moon's resources? If China establishes a moon base first, it could claim priority access to water ice reserves and helium-3 deposits, giving them a huge strategic and economic advantage. If NASA's Artemis missions succeed, the US could set new rules for international cooperation on the moon, potentially limiting China's influence. One thing is certain: the new space race is no longer about just planting flags. It's about power, resources, and the future of human civilization beyond Earth. China's progress has been relentless. In just over 2 decades, they've gone from their first human spaceflight to planning a permanent presence on the moon. They've landed on the far side of the moon, something no one else has done. They've brought back lunar samples for the first time in nearly 50 years. They're planning a moon base before 2035. While NASA is still debating budgets and timelines, China is executing its plans with precision. And if they succeed, the world could be looking at a new era in space, one where China is leading the way. The moon is no longer just a destination. It's the first step toward the future of space exploration, and China might just get there first.